All right, guys, so I'm going to have you fill out in your note packet page 3. So right now you should be flipped to page 3 in your note packet, and we're just going to fill out our notes together so that we can be ready to go on Monday to dive right into some two-step equation practice. So far we have covered solving one-step equations where we're using inverse operations, right? Inverse operations. And so our inverse operations are ones that undo each other. We had addition and subtraction, and multiplication and division. So those are our sets of inverse operations that we'll be using, and we're going to use them to go ahead and solve two-step equations as well. So don't forget, and you should be filling this in with me, that the goal of solving equations is to get the variable alone on one side. And we do this by using inverse operations. Addition and subtraction, multiplication and division. And don't forget, an equation is like a scale and must remain balanced. So whatever we do to one side, we have to do to the other. Give a little smiley face. So if you need to pause the video to make sure that you got everything written down on the top of page 3, please do so. If not, continue on with me to a few example problems. So the first example problem we have is x divided by 2 plus 5 equals 11. So to solve problems like this, we're going to pretend like there was an actual number in there for x, because that's really what a variable is. It's a number we don't know yet. So pretend it was 10 divided by 2 plus 5. According to order of operations, I would want to divide by 2 first. That's a division symbol. And then I would want to add PEMDAS. So division comes before addition. But we are solving, and when we solve, we work through reverse order of operations. We work backwards using our inverse operations. So to undo the plus 5, we need to use the inverse operation of subtracting 5. And to undo the division of 2, we need to multiply by 2. So when I go ahead and I solve this equation, I'm going to draw my line. And the first thing that I need to undo is the addition, because I'm working backwards through order of operations. So I'm going to subtract 5 from both sides. Plus 5 minus 5 leaves me with x divided by 2. 11 minus 5 leaves me with 6. Need to extend my line a little bit. And the thing that's happening to x now is it's being divided by 2. The opposite of dividing by 2 is multiplying by 2. So to undo division, I'm going to multiply both sides of the equation. Whoops, that was weird. By 2. Leaving me with x on the left-hand side equals 12. And so to check my work, to make sure that I did this correctly, I show my check step. And I'm going to replace x with 12 in the original equation. So I have 12 divided by 2 plus 5 equals 11. Well, 12 divided by 2, I have to do my division first, is 6 plus 5. And 6 plus 5 is 11, so that checks out. If I look at my next problem, according to order of operations, multiplication comes first. So we're multiplying x by 5 first, and then we're adding 9 to it second. So if I'm going through and solving, I need to go backwards through order of operations using my inverse operations. So the opposite of adding 9 is subtracting 9. That'll be the first thing I do to solve for x. And the opposite of multiplying by 5 is dividing by 5. That's division sign. So let's go ahead and draw our line. And the first thing that I want to do is get rid of the adding 9 because I'm working through reverse order of operations. So I subtract 9 from the left and I subtract 9 from the right. When I subtract 9 from the left-hand side, I'm left with 5x. 9 minus 9 is 0, so they cancel out. 24 minus 9 is 15. And then to undo multiplication, because that's really what's going on here, 5's multiplying x, I'm going to divide by 5. And I'm left with x equals 15 divided by 5 is 3. And then my last step is to check and make sure that that balances out, that both sides are equal. So I plug in 3 for x to the original equation, just replace x with 3. 5 times 3, multiplication first, is 15 plus 9. And 15 plus 9 is 24. So that checks out. If you need to pause the video to make sure that you have this all written down, please do so. And I also would like you to try the ones down at the bottom. So please make sure you try this problem and you try this problem. So when you come into class on Monday, I'm looking to see that you have those things done. Have a great weekend, guys.